Recent observations captured by the James Webb Space Telescope have shocked and amazed researchers, revealing new cosmic details that challenge the foundational understanding of the universe. Instead of advancing our comprehension of the early universe, these astonishing images have unveiled a disturbing truth: our current grasp of the universe's origins may be far less complete than once believed. These findings are forcing scientists to re-evaluate established theories and consider fresh perspectives about the universe's beginning. The universe's early stages, once believed to be within reach of scientific comprehension, now seem even more elusive, pushing the boundaries of what we thought we knew. At the heart of this lies a deeper question: how exactly did the universe take shape, and why did it develop the way it did? This new discovery is shaking up the scientific community, even challenging experts who have spent their lives studying cosmology and the Big Bang. The findings demand a more refined understanding of the dynamics that shaped the universe. Contrary to popular understanding, the Big Bang wasn't just an explosion within some pre-existing space, it represented the actual creation of space itself, along with matter and time, approximately 13.8 billion years ago. This moment is central to our modern understanding of cosmology, as it involved an extraordinary event where gravity and spacetime reached unimaginable conditions. Today, billions of years later, we know that the universe is in constant expansion, a revelation that is crucial for experts trying to unravel the mysteries of how everything began. Space itself is expanding, rather than galaxies moving through pre-existing space, and this expansion has continued since the very inception of the universe. According to conventional theory, the universe emerged from the Big Bang, and after a period of rapid expansion known as inflation, the first stars began to form between 200 and 300 million years after the event, ending what is often referred to as the Dark Age of the universe. During this period, galaxies began to take shape, clustering together to form the larger, more mature structures we see today. However, the rapid development of these early galaxies has remained an enigma for scientists. The latest pictures captured by the James Webb Space Telescope in July 2022 have added new layers to this mystery. Experts were astounded when they discovered several galaxies that had already formed just 300 million years after the Big Bang. Compared to the enormous cosmic structures that developed billions of years later, these early galaxies were much smaller and less massive. This discovery fits well with the scientific models previously accepted by experts. According to these models, the density of matter in the early universe was not enough to form galaxies as large as those observed in the present day. However, the discovery of 6 strikingly redshifted, luminous objects has sparked what may become one of the most significant crises in modern astronomy. These new galaxies, despite being as old as the ones recorded before, are nearly as massive as our own Milky Way. This raises several significant questions for cosmology. How could such massive structures have existed so soon after the Big Bang? The near-infrared camera on the James Webb Telescope has provided crucial data, showing that the light from these galaxies took more than 1 billion years to reach us. This means we are observing objects that existed between 570 and 700 million years after the Big Bang, and these galaxies were already mature and massive in a way that contradicts earlier theories. Experts have inferred from this data that the James Webb Telescope has revealed early galaxies that are far larger than anyone expected. These structures are not the dwarf galaxies that current models predict for the early universe, but rather massive galaxies comparable to our own. How could these structures have formed in such a short time, with galaxies 10 billion times the mass of our Sun already in place? One of the objects detected could be as large as 10 billion solar masses, though this remains a matter of debate. Even if this is an overestimate, the very existence of such massive galaxies so early in cosmic history presents a puzzle. If confirmed, these objects would defy almost every current cosmological theory, and the density of matter in the early universe would have to be revised significantly upward to account for their formation. This new information has caused scientists to question fundamental assumptions about the Big Bang and the development of galaxies. Even if only one of these newly discovered galaxies turns out to be as massive as predicted, it would force a re-evaluation of how the universe's structure evolved after its birth. Additionally, the early universe must have contained far more matter than previously thought, which contradicts almost all established cosmological hypotheses. There is also the possibility that these galaxies formed through processes that are still entirely unknown to us, representing a new kind of cosmic phenomenon. This revelation, along with the ongoing debates it has sparked, has led some experts to distance themselves from the Big Bang theory altogether. Many astronomers with alternative views are voicing their perspectives in scientific journals, challenging the traditional ideas about the universe's origins. Even scientists who still support the Big Bang theory are confronted with more questions than answers in light of these new findings. One of the core issues under scrutiny is the concept of something arising from nothing. Could the universe have truly emerged from nothing, or was there a triggering event? Or perhaps, was it all a random occurrence? Stephen Hawking argued that time, as we know it, began with the Big Bang, meaning there could have been no external cause for the event. Yet, many questions remain unanswered, including how and why the universe seems to be so uniform in its distribution of radiation and matter. The universe appears remarkably similar in all directions and across vast distances, which has traditionally been explained by the theory of cosmic inflation. Inflation proposes out any irregularities. However, new data suggests that inflationary models may need to be adjusted. One theory, turbulent inflation, extends the concept further by proposing that inflation stopped in some areas but continues in others, creating bubbles that could form entirely separate universes, each with its own physical laws. This idea, which suggests that our universe is just one of many in a multiverse, has profound implications for cosmology. What if the universe is not the entirety of existence? What if another universe existed before our own? This leads to even more speculative ideas about the nature of reality, including the possibility of a cyclical universe where each Big Bang is followed by an era of decay and then rebirth. Other cosmologists have considered even more controversial explanations for these cosmic mysteries. Some argue that the universe may never have had a beginning at all. In this view, the universe could be eternal, with no Big Bang marking its origin. Instead, the universe has always existed in some form, and the constant evolution of matter has simply given the appearance of growth over time. Another fascinating hypothesis comes from the realm of quantum physics and string theory, which suggest that our universe might be a higher-dimensional projection or even a simulation. Though this sounds like science fiction, some researchers speculate that advanced civilizations could create simulations so complex that the inhabitants, us, wouldn't know they were living inside one. If a Type 3 civilization, one capable of harnessing the energy of an entire galaxy, exists, it might have the ability to create a simulation of an entire universe, much like ours. Such a scenario raises profound philosophical questions about the nature of existence and our place in the cosmos. The James Webb Space Telescope's latest findings push us to explore even deeper into these cosmic mysteries. By observing the universe's earliest moments, we are not just challenging old ideas but opening doors to entirely new ones. These discoveries are prompting us to question the fabric of reality itself and driving scientists to reconsider the very foundations